gas is unaccounted for. He must still be up in the lab, up there.
Where's that fire coming from?
The lab, that's where it all started. It's full of toxic fumes.
See if we can get there from inside.
Television and movies affect the way we think about fire. How often have we seen a Hollywood hero rescue a fire victim trapped by a blazing inferno? We witness these acts of Hollywood bravery and mistakenly believe that we could do the same. But in a real fire, there's no special effects crew standing by to raise and lower the flames or magically remove the smoke. Hollywood fires are a clever illusion. They look like real fires, but unfortunately there's an acute difference between illusion and reality.
I thought I was gonna burst into flames. I thought my clothing was gonna burn. That's how hot everything around me got.
It was terrible. It was like a nightmare. It was worse than that.
The smoke was very thick. You couldn't see in front of you. You couldn't see a foot in front of you.
All of a sudden, you open the door to a hallway, smoke pours in. 3 seconds or so, the room was entirely filled with smoke from floor to ceiling.
You know, if there's one thing I remember is the darkness, just like having your eyes shut.
Fighters and fire victims, they know the difference between illusion and reality. They know what's missing from the Hollywood fire. It's dense smoke, toxic gases, and incredible heat. Those of us who have not experienced fire think of it in controlled situations. A fireplace, a gas stove, a barbecue, a pile of leaves. But an uncontrolled fire, that is something quite different. These are the charred remains, the final product of a brutal enemy called fire. This was once someone's bedroom. Now all that's left is blackened rubble. A few barely recognizable possessions, like this television set. Most people never expect to meet this enemy. It happens to someone else. But the truth is, it can happen to any of us, like the fire that gutted this residence. The alarm came in at 4:05. The firefighters arrived at 4:07 and saw this. Firefighters call the type of fire that destroyed this house a structural fire, a rather dispassionate description of a most deadly occurrence. A fire in a building is relentless. It destroys, injures, and kills, spurred on by dynamic forces that most people don't know about or understand. Too often, the tragedy of this toll does not move us to action. We must begin now to understand the real dangers, the actual behavior, the invisible perils of a structural fire, how it grows, how it spreads, and why it is so deadly, before we too become victims of this brutal enemy. Through the use of animation, we can show how a fire behaves. Let's start with smoke, the most common cause of death in home fires. Large volumes of smoke are often generated well before the flames and heat of a fire are of any real danger. What few of us understand is that the majority of fire victims do not succumb to flames. They don't burn to death. They die from smoke inhalation. Smoke is made up of visible particles of unburned fuel and heated invisible gases. The hot smoke is buoyant, causing it to rise. It collects in the upper portion of the room, trapped by ceilings and walls. Consequently, in all fires, the most breathable air will be nearest the floor. That is why people trapped in smoke should crawl low. However, as the fire continues, the smoke level will descend, gradually getting closer to the floor. If a door is open, the buoyant nature of the smoke will cause it to travel rapidly out of the room, seeking higher levels. It will move along corridors, through open doorways, and up staircases, the paths most often used for escape. It will stop only when it reaches a barrier, a ceiling, wall, or tightly closed door. Closed doors have saved many lives. Smoke spreads quickly, and people in rooms distant from the fire are likely to be in serious danger well before the flame and heat of the fire reach them. Unfortunately, when proper smoke detection equipment is not installed and functioning, many people die in their sleep of smoke inhalation. What makes smoke so dangerous? We're all familiar with the invisible deadly gas found in car exhaust, carbon monoxide. In a fire, this gas is always present. Virtually all materials, such as wood, cotton, plastics, literally all the contents of your home will release this toxic gas once ignited. Carbon monoxide interferes with the ability of blood to carry oxygen to the brain. A person caught in a room full of smoke is in extreme danger. The toxic fumes cause confusion and severe disorientation. This mental state frequently prevents victims from getting out, even if an escape path is open. Eyes tearing, body racked with coughing, visibility obscured, consciousness slipping, escape next to impossible. Flames and heat are also lethal products of fire. Flaming combustion can occur when the necessary quantities of heat, fuel, and oxygen are present. Heat causes the fuel to decompose, releasing combustible gases. It is these gases, not the solid fuel itself, which produce flaming. As the fire spreads, more fuel is decomposed, releasing larger amounts of combustible gases. Buoyancy causes the flame to travel upward, igniting whatever fuel source it encounters, spreading quickly to furnishings, drapes, wall finishes, ceiling materials. Even when there is no apparent solid fuel source, combustible gases may be present. And so, like smoke, flames travel along hallways, upstairs to distant rooms, far from the fire's point of origin. We have seen how fire behaves. Now, let's watch what happens when a real chair begins to burn. Note that our chair is in a room surrounded by typical bedroom furnishings: a bed, pillow, bedspread, dresser, wall hangings, draperies, and carpeting. Although this room has been constructed in a test facility, all its contents were purchased at consumer outlets. Their response to fire is similar to the furnishings in your home. An electric coil, acting like a carelessly dropped cigarette, is heating this upholstered cushion, causing smoldering. Smoldering is slow combustion, taking place on the fuel's surface. Smoke is present without flame. Smoldering can sometimes go on for hours before developing into flaming combustion. Although smoke develops slowly in this phase, given enough time, it can fill a structure and kill occupants before any significant flaming is present. The fire is now progressing into the flame-producing stage. Flaming combustion can only occur when the necessary quantities of heat, fuel, and oxygen are present. Right now, we have a small flame. It is rapidly progressing into a substantial fire. As we noted earlier, the heat from the fire is producing combustible and toxic gases from the burning chair. A smoke detector has been placed just outside the room. The fire has now given off enough smoke to activate the alarm, telling occupants to make an immediate escape. The buoyant nature of the gases released from the burning chair causes the flame to spread upward. Heat from the rising flames quickly ignites the draperies en route to the ceiling. The temperature at the ceiling above the chair is now 570 degrees Fahrenheit, 300 degrees Celsius. If a residential sprinkler had been placed 8 feet diagonally from the corner, it would now activate, sounding an alarm and discharging water. Fire damage would be confined to the chair and curtains. The buildup of smoke and its toxic gases has now thickened into a hot, dense cloud in only 70 seconds since the first appearance of flame. This mushrooming cloud of hot, thick smoke and gas begins to act like a space heater, radiating heat downward. The paint and wall finishes, the furniture, paper, fabric, wood, and plastics in the room are beginning to decompose from the blistering heat. And as they decompose, they contribute to the buildup of toxic and flammable gases. The smoke level continues to descend and is now 4 feet above the floor. The temperature at the floor has reached 212 degrees Fahrenheit, the boiling point of water. The huge quantities of smoke have now almost filled the room. The flow of hot air and radiant heat from the layer of smoke have combined to raise the temperature of everything in the room. The carpeting and other furnishings are now so hot that they are ready to burst into flame. And then, flashover. Every flammable object in the room has almost instantaneously ignited. The combustible gases from the decomposing furniture are being consumed by fire. The room itself is an inferno. From a tiny flame on a chair to a room totally involved in fire took only 2 minutes. Carbon monoxide and other toxic fumes are now being generated in tremendous quantities. The temperature inside the room is 1,400 degrees Fahrenheit, 760 degrees Celsius. A room that flashes over becomes like a furnace unable to contain the heat it is generating, unleashing incredible flame, heat, and toxic gases throughout a building. You are among the few who have seen this phenomenon and lived to tell about it. What happened? Let's look again through the lens of a slow-motion camera. The fire, confined to the chair at first, traveled upward, igniting everything flammable in its path. Meanwhile, the smoke and its toxic gases collected at the ceiling and descended, eventually filling the room and severely obscuring visibility. This hot cloud of gas and smoke radiated its heat to the walls and furnishings, causing them to decompose and release even more combustible and toxic gas. The hot air and radiant heat raised the temperature of everything in the room. The bedspread, the pillow, the bed, the carpeting have all burst into flames. The orange glow tells the story. Flashover has occurred. What you just saw, of course, was a laboratory demonstration. But events like this take place every day in real life. This house, for example. The fire started here when an electric space heater placed too near a bed ignited the bed's blankets. Soon the mattress was on fire and the room was filled with hot, dense smoke. In only a matter of moments, the bedroom reached flashover. Flames and smoke engulfed this floor and spread up the stairway to the next floor. Quick action by trained firefighters saved the occupants and the structure. So, what can be learned from all this? Recognize that even a small fire can quickly spread smoke and its poisons throughout your home. And the longer a fire has been in progress, the less time you have for escape. So give yourself early warning by installing smoke detectors. Put one outside of each sleeping area and at least one on every level of your home. In addition, realize too that even a small fire can grow with staggering speed. So make sure you have an escape plan already worked out for you and your family. A good plan has 2 escape routes out of every room. If one exit is blocked because of intense heat, flames, or smoke, then the other route can be taken. If you must pass through smoke, remember smoke rises. So crawl along the floor where you'll find cleaner air. Remember, a structural fire can be lethal. Don't underestimate it. Get out, stay out.